on Thursday the 7th of January, you guys will be able to divide monomials, okay? 6.2, okay? So there's more exponent rules, okay? And a lot of these are dealing with division, okay? So a lot of the ones we dealt with the other day dealt with multiplication, right? Okay? Dealt with multiplying things. So these are going to deal with division, okay? So typically, we know multiplication and division to be what of each other? Opposites, right? The math word we use for that, does anyone know the math word we use for that? It starts with an I. Inverse. We use the word inverse operations. Have you guys heard that word before? Okay. Yeah. Inverse operations. Okay, they're opposite of each other. They undo each other, okay? So a lot of times, when you do one thing for multiplication, you do the exact opposite thing for division, okay? And we're going to see a lot of that same theme here. So we have more exponent rules, okay? So we have rule number 4 we're going to start with, okay? Rule number 4 we're going to start with, and it's dividing monomials. So when you have a to the nth divided by a to the nth, notice it's a and a again, just like before, we get a to the m minus nth, okay? Subtracting the exponents. Let's do some more exploration, okay? I think that really benefited us the other day, and so we're going to continue that now. So let's say we have a to the power of 6 over a to the power of 2. Once again, we're going to keep rolling with those a's. We're just going to replace the m with 6, the a with 2. Now, a to the 6 is iron. Please write this down, okay? A, please write this down, okay? A to the 6 is how many a's multiplying together? 6 of them, right? Okay, that's what the exponents means. So there's really 6 different a's on the top. Now on the bottom, how many are there? 2. Okay? So we have on the top 6 a's multiplied together. On the bottom, 2 a's multiplied together. That's what that literally means. Okay? That's what that literally just means. Okay? So let me show another aside example for a moment, okay? You don't have to write this part down. But let's say we had 6 over 2. Okay, so technically, you guys know that you guys can reduce this and say, oh, that's 3, right? 3 over 1, okay? Well, here's the math behind that, okay? Here's the math behind that works. 6 is 3 times what? 2. So if I put that 3 times 2 over 2, are these equivalent? Do those mean the same thing? Yeah, because 6 is 3 times 2, right, Olivia? Okay. And then, now, what we can do since there's multiplication is I can say, oh, okay, 2 and 2, I can reduce those. Divide that by 2 and 2, take away those 2's. And I'm left with 3 and 1. That's the math behind it. Okay, does that make sense or no?
Yes.
Okay. So over here, do we see any ways that we can apply this right here in the purple and orange to this right here in the blue?
How would it do that? How would it do 3 over 1? I don't get that.
Okay. Like, where does the 3 come from? Where does the 1 come from? Why do we get... Okay. So, you know that 6 divided by 2 would give us 3 normally, right? We can say, oh, 2 goes into both. Okay. So the math behind it is saying that 6 is equal to 3 times 2, right? Like, we agree that the purple is equivalent, right? Okay. So you have a 2 on the top, a 2 on the bottom, and when you're dividing, you can say, oh, 2 divided by 2 would give us what? 1. So you can say this is like 3 over just that 1 that was on the bottom. So you'd end up having like 3 times 1 and just a 1 on the bottom. And 3 times 1 on the top gives us 3, and 1 on the bottom just gives us 1, which is just the same thing as 3. Does that make any more sense? Yeah. Okay, thanks for asking that, okay? So, do we see any ways that we can apply this over here in the purple and orange to this up here in the blue with all of those A's? Okay, Tucker, what are you thinking?
So it's pretty much just the same, but you change the variable.
Okay.
You keep it the same, but instead of having it just be 6 and 2, a to the 6 and a to the 2nd.
Okay, so this a to the 6th and a to the 2nd would be like the 6 and 2. So what would that make this part like? The A's all on the top, the A's all on the bottom. What would that make this part like in here? Would that make that kind of like the 3 times 2 over 2? Yeah. That kind of would the expanded version, okay? And then what did we do when we were at the step with 3 times 2 over 2? When we saw the same thing on the top and the bottom, what did we do? We crossed them out. We simplified those out. We divided them out. Okay, do we see some of the same stuff on the top and the bottom? Yeah, so what do we think we might be able to do with some of those? Simplify them out, divide them out, okay? And in the physical way you see it is crossing, okay? So I can divide out an A and an A. And those both became what? What did we say A divided by A is? Anything divided by itself is? 1. So that just becomes times 1 and times 1. Okay? Do we see any more A's we can do that with?
Yes.
One more.
Yeah, we see one more. Turn that into 1. We can turn that into a 1. Any more we can do it with? No, we're out of them. We're out on the bottom. We have more on the top, but we're out on the bottom. So what do we have on the top now? How many A's do we still have? 4. Now, if we have 4 A's, that's A to the what? 4th. Now, do we need to say A to the 4th times 1 times 1? No, because what's 1 times anything? The other number, right? So A to the 4th times 1 would just give us A to the 4th. Okay. Now, what do we have on the bottom? What's 1 times 1? 1 times 1 is 1. Do we need to even write the over 1 part? No. So really what we end up doing is going straight from A to the 6th over A to the 2nd. And with this rule, we can take this shortcut and just get to A to the 4th. Well, what would we do with 6 and 2 to get 4? Subtract.
That's it.
Yeah. That's our shortcut. So when dividing powers with the same base, remember we need the same base, like not x's and y's, okay, but x's and x's or a's and a's, we blank the exponents. Heard it? Subtract. Okay, when we're dividing powers with the same base, you subtract the exponents. When you're dividing powers with the same base, you subtract those exponents, okay? And so this rule is really just our shortcut that helps us get there.
Then why is there an answer over here? Different answers.
Sorry, say that again?
Why is it different answers then?
What do you mean different answer?
3 and 4? Like why is this one?
Oh, here versus this?
Yeah.
Okay. This was a different problem. That was an example problem. This was purple and orange off to the left. That was just an example problem to show us kind of how that dividing out works. Yep. They're completely separate. Yeah, good question, okay? Any other questions on that before we start applying this rule, this shortcut? Okay, what I'm hoping, guys, is these little expirations help it make more sense to us and help it kind of stick to us better, okay? That's my hope, okay? So here on number 1, s to the 3rd over s squared. Are these the same base? Yeah, remember base is the number or the variable that is being raised to an exponent. So those are the same base, s's. Now what is happening with these bases? What's happening with the s to the 3rd and s to the 2nd? They're dividing. So this rule says when dividing powers with the same base, is that happening right now? Are we dividing powers with the same base? Yes, we are. So what are we going to do? Subtract the exponents, okay? Now notice, did we do the bottom minus the top?
Yes.
No, we subtracted 2 minus 6 minus 2.
We did the top minus the bottom. That was a tricky question. That was a trick question, okay? We do the top minus the bottom. So it's going to be what minus what here? 3 minus 2. And so we get s to the first. Do you even have to write the 1 there?
No.
Then just call that s. Now the long way of doing that, which we could do again if you wanted, would be s times s times s on the top and s times s on the bottom. And go through and say, okay, well, s divided by s, that's 1, that's 1. S divided by s again, that's 1, and that's 1 again. And then say, oh, I have one s left, and none on the bottom, okay? You guys can do that every single time, but you don't have to, okay? Questions on that at all? Okay. On the second one, we have a little bit more going on, don't we? Okay, we have a little bit more going on. We have a few more variables now. Okay. Well, does anyone have any ideas on what we might do? On how this might go? Okay, Mason? You said yeah? Yeah, go ahead.
You do x5 minus x2, and then you do y minus, like y over 3 to y, and then z.
Okay, so you do the x's together, the y's together, and the z, okay? So the x's are dividing, okay? So we subtract the exponents. What's 5 minus 2? 3. So we end up getting x to the 3rd. Okay? Well, then we have to do the y's. So what do we end up getting from the y's? Y to the 2nd. Yeah, very good. And then, do we have anything z's on the bottom? No, so we just leave the z there on the top. Okay, there's nothing. That was like in our earlier example when we had that 3, and we just had to leave it. So So we get x cubed y squared z. Does that look a lot cleaner than what we started with?
Yep.
Yeah.
I think so. I think so. In my opinion, I think so. Okay, question on that at all? Okay. I want you guys to try number 3 on your own. When you have it or have questions, raise your hand. So b to the 14th over b to the 4th, same base, right? So we subtract them, we get b to the what? 10th. And that's our answer. Okay. Could we write out the whole thing if we wanted to do like b times b times b times b times? Wouldn't that be a pain though?
Yeah, okay.
That's why these shortcuts are so nice.
Or you could just
Do people do that, though?
4.
Yeah, you can just do 14 minus 4 and say 10. What was that?
People do that though.
Yeah. I think it's silly, but you can.
Have you seen someone do it before?
Like not like after I teach it normally, but like you can. I think it'd be silly, but you could.
It's silly.
Okay, but hey, here's the thing though. If you're on a test and you forget what rule is what, like what do I do in this situation? Could you write them out and then kind of figure it out from there? Okay, that's something I've done before. Okay, sometimes when I've taken tests over this and I'm like, oh, what was that rule again? Like, which way did this one work? Because like honestly, like when you get so much math in your brain, you make some stuff up, right? Like that's real. Okay, that's a thing. Okay, so like sometimes I'll write it out and be like, oh yeah, that's how this works. Okay, I subtract here, kind of a thing. Does that make sense?
Yeah.
Okay. Or like when you're multiplying, like, oh, I add them. Oh, okay, that's what I do. Anyway, continue on. We got rule number 6, okay? Woo, rule 6, okay?
Rule 5, you mean?
Okay. What? Oh, did I just skip rule 5?
I mean, we don't have to do it.
Oh, that's kind of brutal. I just legit skipped rule 5.
Oh, boo.
Maybe
That's awkward.
Seriously, I said something to
Not me.
that was you?
It's Big Sad, Mr. Cole.
That is big
Wow,
sad.
I didn't say anything.
I'm gonna start.
Oh my goodness.
I'm walking out. This is bullying.
Okay, well, hi, walking out. This is Bull Name, Mr. Customer Speak, okay? Well, here's what we're going to do. Rule number 5. Power of a quotient.
Write it out. Oh no.
Yeah, lock it up.
I'm not going to write out the whole thing, but I'll write out some of it.
Why not?
Oh, that's a lot of time to write out the whole thing, dude.
Oh, come on, let's do
A
it.
over B to the mth equal to A to the mth over B to the mth, okay? So here we see power of a quotient. Quotient is what? What's quotient mean?
Number.
I didn't hear what you said.
Ah,
Divide. Multiplying means the answer to a division problem. We had product the other day. Remember power of a product? Okay? That's multiplication. Quotient is division. Power of division. Okay? So we have, what do we have in the fraction here? What type of problem?
division.
Division. A divided by B, or over B. And it's being raised to a power. So a fraction, a division problem, because fractions are division, is being raised to a power. And what do we see happen? We put the m on the top and the bottom, didn't we? Is that kind of similar to what we did before?
Yeah.
Yeah, but now we have a bottom too that we do it. Okay, let's look at the exploration for this. Okay, so this is the exploration. So let's say we have a over b being squared. Okay, a over b being squared. So go and write this down with me. If I can write the whole thing out, so can you. Okay. Right, Aiden? If I can write out the whole thing, then so can you. Okay? A over B being squared. So what's a square mean? Times itself
no, it's a
twice.
number
There's
twice.
there's 2 of them. There's 2 of them multiplying together. So we have 2 of whatever's in the parentheses. So here, what do we have 2 of? A divided by B. So we have A divided by B times A divided by B.
I thought that was a 9.
Nope, no, my bad. I can see that though. A divided by B times A divided by B. We have 2 of them multiplying together. That's what square means. So when you multiply fractions, we multiply straight across, right?
Yep.
What's A times A?
A. Double A to the second.
A to the second. We add the exponents. 1 plus 1 is 2. What's B times B on the bottom?
B to the second.
B to the second. We got that one a little bit quicker. Okay? So we ended up having, from start to finish, kind of this shortcut where we ended up taking this 2 and we distributed it to whatever powers were there. Okay, so just like before, exponent on the outside of the parenthesis, we're going to distribute it to the power that's there, okay? So the blank to find the power of a quotient, find the power of the numerator. That's the first blank. Find the power of the numerator. And the power of the denominator. Those are the two blanks. So you distribute it to the exponents in the numerator and to the exponents in the denominator. Pretty similar to the rule we had before, right? Rule number 3. Pretty similar to rule number 3. Questions on that? Okay.
We have map testing.
Yep. We will have map testing on Monday. Okay. I found out yesterday we're gonna have map testing on Monday. So make sure you bring your laptops, okay, and have them charged. Okay. What was that?
Did we ever do that in here?
Yeah.
We did?
Yeah.
We did it, I think, at the beginning of the year.
You might have been gone at the beginning when we did at the beginning of the year.
He was gone towards the beginning of the year.
So,
It was.
yeah. You had to go into quarantine after the first day.
Yeah,
I did.
Yeah, you don't remember that?
I remember that.
It legit happened.
You
My
were
other
in your own
brain.
quarantine?
Oh, because like,
Oh yeah,
How do you
he was
go to
in
the
there for a
nurse?
while.
Oh. I remember you had to go to quarantine. Okay. Anyway, so here's number 1. Or I guess there's a period there. 2x to the 4th over 4 being cubed. That's number 1, right?
yeah.
Okay. There's actually 2 ways you can do this problem. There's actually going to be 2 ways we can do this problem. We're going to walk through both of them, though, okay? I think you're going to like one more than the other. Okay? So, according to our rule, what do we have to do with this exponent?
Divide it.
Distribute it, right, to all the exponents. Am I doing 3 times 2? No. 3 times what?
4.
The 1 that's secretly there, and the 4 on the top. And then what about on the bottom?
You have to do it too.
There's secretly a 1 there as well, and we have to do that too. So this becomes 2 to the what? Third. X to the 12th. And Zyron, 4 to the what on the bottom? What's the bottom become? 1 times 3 is what? 3. 4 to the third. 4 to the power of 3. Very good, very good. Questions on this so far? Okay. 2 to the third. What is 2 to the third? We can actually do that exponent, right? Walk through order of operations exponents now, okay? 2 to the third is 8. Can we do x to the 12th? No. Okay, x to the 12th it is. 4 to the third. Do we know what 4 to the third it is? Then you gave me a weird look. What was that weird look? You gave me a weird look. You're like, what?
Because you said x to the 12 it is.
Yeah, can we do x to the 12th? No? Okay, we're just going to call it x to the 12th. Yeah, I get you now, okay? What's 4 to the third? Does anyone know without using their calculator? Okay, what?
16.
Not quite. 4 squared is. Okay, so
64.
it is 64. Good stuff, good stuff. Did you write it out?
Yeah.
Good stuff. Ooh. 2 to the 5th is 32. But, so now we have 8x squared, or 8x to the 12th, not squared, over 64. Are we done yet? No, what can we do?
Distribute.
Mm,
No.
reduce. Reduce the fraction. What goes into both 8 and 64? 8 goes into both. How many times does it go into 8? Goes into it once. So we really have just x over 12, x to the 12th. How many times does it go into 64? 8. X to the 12th over 8. Now we're done.
Yeah.
Questions on that? We just kind of used our rule, right? Our shiny new rule. Okay. You guys ready to see something else? A different way?
No. Yes.
Okay.
Was it easier?
I think so.
Okay, then I'm ready.
Oh, okay. Weird how that changes, Miss Saswell. Weird stuff, okay? So I just wrote the same problem again, right? You guys see that? Wrote the same problem?
Yeah.
Okay, cool. So, can we do stuff inside the parenthesis before we do the exponent?
Yes.
Yeah.
Why not?
What can we do inside the parenthesis? Reduce. The 2 and the 4, right? What's the 2 become? 1. So we just have x to the 4th. What's the 4 become? 2. So now, when we take this exponent, is there less to do?
Yeah.
Yeah. 3 times 4, x to the 12th. On the bottom, there's a 1 there. 2 to the 3rd. X to the 12th over 8. So what is it always good to check for?
See if we can reduce.
See if you can reduce early. You save yourself from getting big numbers and maybe even bigger on some
Did
problems.
you just do like a turn thing?
I did kind of.
360?
Yeah.
You make a twirl.
Yeah, a 360 no scope. Okay. Okay. Put me on Dancing with the Stars. Okay, just saying. Okay. Don't think of a star? Look at my YouTube channel. 66 subscribers. You tell me. Okay. Anyway. So x to the 12th over 8. Hit that bell. Okay. Anyway. If you like this video, click like, comment, subscribe for more. Hit that bell. Anyway. Okay. X to the 12th over 8.
Keep that in your video too.
What?
Keep that in your video.
I'm not gonna edit it out. It's in there now. But anyway. So this is our answer. And simplifying makes our life easier. Is it necessary to simplify early?
Yeah.
Did we have to simplify early to get the answer?
No.
But if we had to simplify in general, I asked a bad question at first. Okay, we had to simplify in general, but whether you simplify early or late doesn't affect your answer. It just affects how big your numbers got. Okay, and how much work you have to do. Simplifying early, good idea, right, Aiden?
Yeah.
Okay, good thing you wrote down both methods. I appreciate that. Okay, that's really going to help you out later when you don't know how to do something, and then you have questions. Oh yeah. So you're gonna ace it on the test now, right?
No.
Oh, so you might want to write it out.
And you learn it better.
Just saying. You believe it or not, I actually know a thing or two.
Earlier.
Yeah, some you might have heard that before. Okay, let's look at the other question. Okay, so number 2,
Yeah.
we had in the parentheses 5x to the 5th y all over 6, all being raised to the second power. Now this time, can we simplify early?
No.
No, 5 and 6 don't reduce. Okay, so we can't simplify early, but we can still do our exponents, right? Okay, so what can we do anything with this x to the 5th?
No.
Not yet. Okay, we're walking through order of operation right now. We can't do anything inside the parentheses. Can't do anything with this exponent. Can we do anything with this exponent?
Yes.
Yeah. We have to distribute, right? 2 times 5 is 10, right?
Yes.
Yeah.
Wait, do we do that?
No.
No. 2 times 1 is 2. 5 squared, x to the 10th, and this is just y, right?
One to the second.
Y to the second. Good catch, Reagan. 2 times 1. On the bottom, do I have 12?
No.
No, what do I have?
6 to the second.
6 to the second. We need to put it on the exponent, not on the number. Exponents don't multiply with numbers. Exponents multiply with exponents. Okay, got to keep the exponents together. Now, do we see more exponents we can actually do stuff with?
Yeah.
5 to the second. What is 5 squared? 25, haha. X to the 10th. Can we do anything with that 10? No. Can we do anything with the y squared? No. Can we do anything with 6 squared?
Yeah.
Oh, okay, cool. What's that?
36.
36. Anything here reduce?
No.
No, we're done. Okay, could be worse, right? Could be worse. Okay. Questions on that? What's the hardest thing we're going to do? I mean, I don't know. It depends. I think a lot of people might say factoring or quadratics. But quadratics are functions. You guys remember doing functions like the lines and stuff? Okay. Those are functions, but instead of having a first power, you have a second power.
I think you should give us our homework now so we don't forget it.
Oh, yeah? You think so?
Yeah.
You know what? I might just forget that.
And then if we have time at the end, maybe we can do rest.
Maybe you can rest?
No, we can.
Or do the rest. Do the rest. I think about that.
That's a good.
Keep
deal.
going.
No.
Reagan wants to keep going.
If I keep going, I'll
Reagan.
forget these.
This actually might.
Okay.
Think about it.
How about we do this? Okay. With our remaining time, for now, we're going to finish up the yellow worksheet, and I'm going to give you the next worksheet. We're going to do we're going to do about half of it. We're going to do the first 2 rules worth, and then we're going to do the next rules, 7 and 8, or excuse me, 6 and 7. Not next class for map testing, but then Wednesday next week. Does that sound okay?
Yes.
Okay, we'll do that.
1, 2, 3, 4.
I want you to do numbers 1, 2, 5, 7, 9. It is not it. 13, 15, and 22. Okay? 8 problems. 8 problems. It's not as bad as it looks. Let me tell you that right now. It's not as bad. It's not the worst problem on here. It's not as bad as it looks. Yes, now you may go. Okay? So we're going to finish up that yellow worksheet, the 6.1, if you haven't already. And we're going to do these 8 problems on this worksheet, okay?
Okay.